Hi everyone, we're going to be going over PT2, all about metals, which is on page 8 of your packet. So at the end of this, you're going to be able to describe the properties of metals, and we've already talked a lot about them. You should know that already that the largest group on the periodic table is metals. So we've already talked about that and color-coded that periodic table. So what are the properties of metals? So we know that usually they're shiny. We know they're malleable. In parentheses, you want to write in there that means pounded into shapes. Ductile, in parentheses, you want to write that means it can be pulled into wires. So again, in parentheses, pulled into wires. They are good conductors. We saw that in our mini labs. Most are solids, and they have high melting points and densities. Right? And you see some pictures in here you should be familiar with: rust or oxidation of some metals, and the fact that they are typically magnetic. So talking about the alkali metals first, that is group 1. They tend to explode when mixed with water. When it says easily lose 1 electron, what that means is that when these elements combine with other elements, they're going to lose 1 electron easily to combine with those other elements to form a compound. And so when it easily loses 1 electron, that means that they're going to combine with other things fairly easily that need 1 electron. And we'll go over valence electrons a little bit later in the unit. They have low densities. So these are, salt. Lithium, you might think of batteries. Potassium, which is K, you might think of bananas, right? If you have a leg cramp, bananas are going to be helpful to gain that potassium back. And again, just this picture showing that they explode when mixed with water. And notice that, this is our first group, our first family, but hydrogen is not in this. So hydrogen is not an alkali metal. All right, going to group 2, alkaline earth metals. These are also very reactive. They're not as reactive as group 1, the alkali metals. These easily lose 2 electrons, so they're going to combine with other elements that need 2 electrons to form a compound. Some things that you might know: barium. Barium is a liquid that people drink before an x-ray. So it's pretty nasty tasting, actually. And they take that, and then in the x-ray, it comes out this white color so that doctors can see if there's any leaks or anything in the intestines, in the stomach, those kind of things. All right, lots of elements are used in fireworks, so strontium, magnesium. Calcium, you probably think directly about milk. Milk is in a lot of dairy products, okay? Moving on to transition metals. So this is the big group 3 through 12. And these have high melting points and boiling points. They are not as reactive as the alkali metals and the alkaline earth metals. They are used for many household purposes. So you want to list out a couple of those things. So things like silverware, jewelry, cooking pots, and pans. And then I'm going to go over some of these examples, and you can write some of these down as well. All right, so gold and silver, is used in a lot of jewelry. Excuse me. Cobalt, cadmium, you're going to see in different paints and pigments. So colors, they're used to help make colors of paints and things like that. Copper, Some people have copper plated pots and pans. So that's going to help, heat up our foods and things like that. And again, here's the picture highlighted in dark blue of those transition metals. All right, you have the next section is metals and mixed groups at the top of the next column. So groups 13 through 15 of the periodic table contain some metals. So this is right where your stair step is, your staircase is. And so some of these right here in these same groups are going to be metalloids that we've already talked about. So like it's saying in this paragraph here, some of them are metals. They are not nearly as reactive as other metals that we've already talked about. Some of the metals in this shaded blue area right here are tin, aluminum, and lead. And you've probably heard a lot of those. Those have common uses in, our everyday metals that we use, aluminum foil, for instance. All right, the next group is lanthanides. These are soft metals. They are malleable. They are shiny. They have high conductivity. They have high melting points and boiling points. They're very reactive. They burn easily. Okay, and some examples to put on the line there. Neodymium here, ND, which is, this one's kind of interesting. So neodymium is used in really strong, tiny magnets. And if you didn't know, stereos need magnets to create the sound that they're pumping out. And so obviously big speakers in radios and maybe stereos that are used at concerts, those big speakers, they have large magnets, which never was really a problem. But as our speakers have gotten smaller, like in earphones, headphones, earbuds are even smaller, they needed really tiny magnets. So neodymium is used in those really strong, tiny magnets for those headphones. All right. Holmium, again, is used in magnets, and that is used in specialized lasers and things like that in the medical field. So, and again, these lanthanides are in this bottom row, kind of separated from the main periodic table there. All right, the next group is actinides. Those are right under the lanthanides. They have unstable nuclei, so the nucleus is unstable, which makes them radioactive. They tarnish easily just in the air. All right, some examples of the actinides there. We've got einsteinium. Einsteinium has no real uses. It's only used in very small amounts. Thorium is pretty strong, right? So just like Thor in the action movies. And thorium is also used in high quality camera lenses because it is very strong. Curium is used for scientific research. So you see how they're trying to show kind of the robot put on other planets here. The last section is synthetic elements. Synthetic elements are created in particle accelerators. And in that particle accelerator, the nuclei of two different elements are crashed into one another. And this creates new elements. So for instance, curium is created by colliding helium and plutonium. And so this is the big particle accelerated. You would think that it was smaller, right? Because we're crashing nuclei, which are really, really tiny. We can't even see them with the naked eye, right? Well, no, we need a huge machine to do that. And then we can see some other uses, smoke detectors, medical equipment again. right? And you have your stems down at the bottom. Stems, syn, S-Y-N means together. T-H-E, the is put, and I-C is of or like, right? So if we put that all together, it means of or like putting together. So these are put together by man. Synthetic elements are man-made. All right, at the bottom of page 8, you have some pictures and you are identifying the characteristics of the metals. So you might want to just try these kind of on your own. But the first one is showing an iPhone plugged into the wall outlet. So obviously that's showing electrical conductivity. The cord is also showing that it's ductile, right? So there is some metal inside that cord. Gold rings are going to be malleable. They were able to form them into rings, so this gold is malleable. It's also shiny. All right, this wire is ductile. If we have a glass or a cup of hot coffee and we stir it with a metal spoon, that's going to show thermal conductivity. The strings of the guitar are obviously ductile. They've been pulled into a wire. You created a circle in one of your circuit in one of your mini labs. The wires here are ductile, and they are also conducting electricity, so electrical conductivity. All right, pennies or any coins really are malleable, so that metal has been pounded into those shapes. And then it could be shiny, so you can't really see that in your picture there, but a lot of metals are shiny. All right, at this point, you can also fill out your study guide on periodic table 2, the metals, by using the notes we just went through. Have a good day.